let's focus on some figures for Chapter 9 and some of the orbital controls on monsoons. Now, before we get into that, let's discuss what a monsoon is and how it forms. Now, monsoons are due to reversing wind patterns, and they're cycles of wet summer seasons and dry winter seasons. That's a full monsoon cycle. And the way this works is the heat capacity of land and water is different from each other. Now, water has a high heat capacity, which means that it takes more energy to change the temperature of water than it takes to change the temperature of land, which is mostly rock and soil, right? So just think about a summer day. When you go outside and you step onto the pavement, it's really hot, or your deck, it's really hot. But if you pour water on it, you can walk on it just fine. That's because water has a higher heat capacity than wood or rock. Now, looking at the summer, you'd expect then for the land to be at a higher temperature than the water. So we have this hot land surface and this cooler ocean surface. And so what happens to hot air? Well, when air heats up, it expands and it rises, because when it expands, it becomes a lower density than the surrounding air. So the air expands and it rises up, creating this low pressure system over the land. And air likes to flow from high pressure to low pressure. So that's what's happening with this cycle here. It goes from higher pressure to lower pressure. So that's where we get this convective cell here. And what happens then when you have a low pressure system over the land is you get these heavy rains. And so this is a summer monsoon. Now, the reverse happens in the winter. In the winter, we have weaker solar radiation, and that means that, as we said before, water has a high heat capacity, so it's not as easy to change its temperature. It's not as easy to warm it up, and it's not as easy to cool it down. And so what's happening here is that the water now is at a warmer temperature than the land. So the warm air over the ocean rises, creating a low pressure system, and the land is at a cooler temperature because it has a lower heat capacity than water. And so then we get dry land conditions during the winter time, and this would be a winter monsoon. Now, one area where this happens a lot is over Africa. And now let's put together some of the things we talked about earlier while we were looking at cycles. So as you can see here, this is showing a cyclical sinusoidal type pattern. And on the y-axis, we're going from present day at the top. So this would be present. I'm just going to write pres because of my lag. And then, present. And then lower down, as we move back down the y-axis, we're looking at 140,000 years ago. So we're looking at monsoon patterns over Africa in this image. And you could see that we get this cycle that matches up pretty well to patterns of precession. Now, we have marked this threshold value right here. So anything that is below the threshold value is colored in yellow. Everything above the threshold value is colored in green. And in this case, what the threshold represents are the conditions with which either the monsoons will be too weak to fill the lakes completely, or they're strong enough to fill the lake. So the green represents the conditions where they're strong enough for lakes to fill, and the yellow represents conditions where monsoons are weaker. And so the lakes do not fill. And so what happens then is these lakes fill, and you'll see when you read through the text some of these different conditions that these different circumstances that happen when lakes fill. For example, the Nile, there's more runoff coming off the Nile, which is saline, and you get this salt cap over the lakes. So definitely go through that and make sure that you have a handle on that process. But another thing to look at is, how do we know when we look back in geologic time when there were stronger monsoons and when there were weaker monsoons, and how does this align with these orbital scale processes we've been learning about? And so we have to be able to figure out how you'd look back at the geologic record. And what we've actually found is these simple prokaryotes called diatoms. They're this type of phytoplankton that are made of silica. Silica is silicon plus O2, so SiO2. So they have these silica shells. And in this case, we're looking at these freshwater diatoms that live in the lakes. And what we've seen in the geologic record is that these diatoms are found offshore in ocean sediments when we're expecting them to be found in fresh water. And the reason for this is that when these diatoms die, they settle out to the bottom of a lake. And when there are weaker monsoons and the lakes dry up, then we get erosion happening in these dry lakes and transportation. So wind-blown transportation of these sediments. So the wind is carrying these little diatom bodies over to the ocean and depositing them there. And so if we look back at ocean sediment cores near Africa, off the coast of Africa, we can see that aligning with these drier conditions, there's of course a little bit of a lag, but aligning with these drier conditions of empty lakes, we find a similar thickness, a relatable thickness layer of diatoms. And so that's some geologic evidence of weaker monsoon cycles. Now I'd like you to go through some of the other figures and see if you can leave your analysis in the forum.